Welcome to this explainer on EPA Method 1A. Let's solve the small duct and stack problem like a pro.
How do you accurately measure emissions when your gear is literally too big for the pipe? In standard setups, a combined probe is fine. In tiny ducts, it creates a massive traffic jam. That physical blockage completely messes up your natural gas flow dynamics, totally ruining your emissions data. So, what's a small duct? Method 1A applies to anything with a maximum diameter under 0.30 meters. But there is a hard limit. Your duct or stack absolutely must be at least 0.10 meters across. One huge caveat though, you absolutely cannot use this method if you've got cyclonic or swirling flow. Method 1A's genius workaround? Simply separating the particulate matter sampling probe from the velocity pitot. Look at this original view of the duct. See how spacing the components out makes it look totally professional? First, you sample the particulates upstream, then measure velocity downstream once the flow has totally restabilized. That straight run between the sites is crucial. It gives the disturbed flow time to settle.
For the ideal setup, the particulate site needs 8 diameters downstream and 10 upstream from any disturbances.
Got tight spacing? The alternative setup drops this to just 2 diameters downstream and 2.5 upstream. But hey, what if your flow rate is perfectly steady? You can actually simplify this whole shebang. If your volumetric flow is constant within a 10% deviation, you just use a single location. You gotta prove it though by doing full velocity traverses right before and after your particulate run. Now let's figure out exactly how many traverse points you need to slice across that duct area. Hit the optimum location criteria. You'll need a minimum of 8 traverse points for circular ducts. And don't forget, for those circular ducts, your final traverse point number must be a multiple of 4. Could your testing gear be ruining the exact flow you're measuring? Subscribe for more professional explainers.